welcome to the Explainer. Ever looked at a map of North America and just seen a chaotic jumble of shapes and colors? Well, today, we're going to effortlessly decode it by building the entire continent layer by layer. We're going to transform this vast geography into a perfectly organized system of land, water, and weather. Today, we're essentially building this continent from the ground up. We'll start with the political puzzle pieces, trace the surrounding waters and straits, and then dive into the invisible forces of weather before finally carving out those massive mountain ranges. All right, let's kick things off with our very first layer, the political map, exploring the nations and neighbors that divide up this massive landmass. When you picture North America, you probably think of the big three right away, right? Canada dominating the north, the US in the middle, and Mexico anchoring the south. But look just south of Mexico. That's not just a narrow strip of land. It's a dense, vibrant cluster of distinct nations. By grouping these Central American countries and their capitals into a quick list, from Guatemala City all the way down to San Jose, Costa Rica, memorizing this vital southern tale actually becomes a total breeze. Now, let's drift just slightly east into the Caribbean Sea, adding another incredibly vibrant piece to our political foundation. Here we find the Greater Antilles. These island nations include major cultural and economic players like Cuba, Jamaica, Haiti, and the Dominican Republic. And here is a fantastic little microfact to help lock this region into your memory. Cuba isn't just a major island. Historically, its massive agricultural output actually earned it the famous global nickname, the Sugar Bowl of the world. Pretty cool, right? Okay, moving on from the land, let's look at how the surrounding water literally carves out the shape of the continent. Because a continent isn't just defined by its dirt and rock, it's defined by the water trapping it. Imagine tracing a continuous line right around the perimeter. We'd start way up in the icy Beaufort Sea, plunge down into the massive Hudson Bay, and slide right down the eastern coast, past the Labrador Sea into the Gulf of St. Lawrence. From there, we swoop all the way south into the warm Gulf of Mexico, hop over to the Pacific side into the Gulf of California, and trace the coastline all the way back up to the freezing Bering Sea. Now, while we're tracing that eastern coast near the Gulf of St. Lawrence, we hit the Bay of Fundy. You absolutely have to know about this spot because it boasts an incredible hydrological phenomenon. It experiences the highest tides in the entire world. It's literally like a massive rhythmic breathing of the ocean that drastically reshapes the coastline every single day. And jumping back down south, we've got the USA's largest river, the mighty Mississippi, dramatically dumping its huge water volume into the Gulf of Mexico. As the river hits the ocean, it rapidly slows down and drops a ton of sediment. Over time, this has built up a highly distinct bird foot delta. If you look at it from satellite imagery, it literally looks like a giant claw reaching right out into the water. So we've got our oceans and gulfs in place. Now it's time to map out the narrow gateways that connect them all together. But really quick, before we dive into them, let's make sure we're completely clear on what a strait actually is. Simply put, it's a narrow passage of water that connects two larger bodies of water while simultaneously separating two distinct landmasses. So think of it as a bridge for water, but a barrier for land. These gateways essentially tear land masses apart. Take the Davis Strait, for example. It's actually the widest strait in the entire world, and it sits there separating Baffin Island from Greenland. Then, much farther south, you've got the Florida Strait, neatly slicing between Florida and Cuba, acting as the ultimate turnstile for water flowing from the Gulf of Mexico right out into the open Atlantic. But this next one is definitely my favorite. Look at the Bering Strait, separating Alaska from Russia. What's wild is that the 180-degree longitude line, the international date line, passes exactly through it. So this water doesn't just separate two continents, it literally separates today from tomorrow. You could theoretically sail across it and time travel. How crazy is that? All right, our physical map is really taking shape. Let's breathe some life into it by looking at the dynamic, invisible forces that dictate the weather. First up, sweeping down the eastern slopes of the Rockies, we have the Chinook wind. It's a warm, local wind that has earned the awesome nickname, the Snow Eater, and it absolutely lives up to it. This sudden rush of warm air can raise temperatures drastically in just hours, creating a jaw-dropping, rapid transformation of an icy, snow-covered landscape right into lush, exposed grasslands.
Meanwhile, just off the coast, there is a massive geographic battle raging in the water. You've got these icy polar flows, like the Labrador and California currents, engaged in a constant tug of war against warm equatorial currents, like the Alaska Current and the famous Gulf Stream. And when these clashing currents finally slam into each other at the Grand Banks off the eastern coast of Canada, it triggers a massive reaction. The brutal mixing of the freezing Labrador Current and the warm Gulf Stream results in incredibly thick fog. But more importantly, it churns up vital nutrients from the deep sea, which creates some of the absolute best, globally renowned fishing grounds on the planet. Finally, let's move to our last layer and see how ancient tectonic collisions literally crumpled the flat land into majestic peaks.
To really understand the continent's spine, we have to look at how it was built. It's really a tale of two mountain types. On one hand, you have the intense tectonic folding of the mighty Rockies, crumpled upward by millions of years of plate collisions between the Pacific and American plates. On the other hand, you have these jagged block mountains that stretch down through the Sierra Nevada and into the Sierra Madre.
And towering above it all, specifically above the Alaska Range, is Mount Denali. This giant punches exactly 6,194 meters into the sky. That staggering altitude makes it the undisputed highest peak on the entire North American continent, acting as this freezing sentinel over the northern landscape. Rounding out our physical map, we have a few other massive ranges that serve as the rugged skeleton of North America. Up in the icy north, there's the Brooks Range and Canada's Mackenzie Mountains, which, by the way, host Mount Logan, Canada's highest peak. Stretching down the western edge is the Coast Range, and contrasting perfectly with those sharp, younger western peaks, you have the much older, heavily eroded Appalachian Mountains bordering the east.
So, we've successfully mapped the borders, the rushing straits, the dramatic weather, and the rocky spine of North America. But I'll leave you with this thought. What massive ancient geographical secrets, like the sprawling Great Lakes, are hiding right in the middle? Because so far, we've really only mapped the edges. We'll be diving deep into the heart of the continent in part 2 of this explainer. You definitely won't want to miss it.